friends, good morning. Myself Raju. I graduated from NEET Puducherry. So currently I am working as a chemistry teacher in Narayana CO school. So today we are going to pick off ionization energy, which is a subtopic in periodic properties. So this is very important topic, and the questions will come directly from this topic, like direct based questions will come. Most of the questions will come as statement questions and like order of ionization energy and decreasing order of ionization energy. So first ionization energy. We should know the definition. Ionization energy. So ionization, what is meant by ionization energy? So ionization energy, nothing but the amount of energy required to remove an electron from a gaseous neutral atom is called as ionization energy. The amount of energy required to remove an electron isolated gaseous neutral atom is called ionization energy. The amount of energy required to remove an electron from outermost shell. For example, if we have this one. So for example, this is an atom which is in spherical shape. So in the atom, you know already, at the center of the atom nucleus is present. So K nucleus is present, and this one is shell. So shells, we know already, the electrons are revolving around the nucleus in the circular paths. Those are called shells. So electrons are revolving around the nucleus in the circular paths. These are called as shells. Electrons are present. So the outermost shell, for example, it has two shells. Just think that it has two shells. Okay. So it has this shell, first shell. In this also electrons are there, and second shell also electrons are there. So at the center of the atom, nucleus is present. In the nucleus, positive charge is there. Why? Because protons. So electrons are rotating around the nucleus in a circular path. So the amount of energy from outside, the amount of energy is required to remove this electron out. Required to remove, here one electron is there, right? To remove that electron, how much energy you need? So that is only called as ionization energy. For example, if we write the reaction, so X is a neutral gaseous atom. So here two more new terms came. Isolated. What is meant by isolated? So isolated, nothing but individual atom. One separated atom we should take. Okay. For example, sodium. One separated atom, not in a molecule. Okay. One separate atom we should take. And then gaseous. So any gas atom. So here sodium is metal actually, but we can take metal also. But generally in gaseous atoms, so gaseous atom, for example, chlorine I will take. So this is also, instead of sodium we can take chlorine also here. Chlorine I will take. It should be neutral. It should be neutral. Okay. It should be neutral. Okay. Why we are taking neutral atom means from there we can remove how much energy. Neutral means there should be no charge. Okay. Neutral atom we should take. These three other conditions for isolated like ionization energy. So the amount of energy required to remove an electron from its outermost shell from the isolated gaseous neutral atom is called as ionization energy. Now for example, if I take like next page. For example, X is a neutral gaseous atom. Neutral gaseous atom. So amount of energy we need to give it. So we need to add it. Less energy, some energy. Okay. And so, when electron is getting removed from the neutral atom means what charge the neutral atom will get? Plus or negative? Plus, of course plus. Why? Because electron losing means in chemistry, plus means loss of electrons and gain means negative charge, gain of electrons. Why? Because electron has negative charge, so that's why gain means negative charge is coming inside. So negative charge is coming inside, that's why we have to give. It is not like mathematics. In mathematics means the negative means subtraction and plus means addition. No, not like that. Here reverse, because the electron has negative charge. So plus one electron also coming out, right? This electron. Okay. So here we are giving the energy to remove electron from X neutral atom. So the X atom released one electron out and it got X plus positive. Uni positive we can say. Uni means one positive. So this is IE1. We can declare the ionization energy with IE1. Okay. Why means like first electron removed from the neutral. So we form neutral unipositive ion. So here energy is releasing or observing? Energy is observing. By observing energy only it is losing the electron. So energy observing means these type of processes are called generally endothermic process. So that's why these ionization energies energy processes are generally, no, always, not generally, always endothermic. Endothermic means endo, coming inside, thermal, heat energy is observing there. Always endothermic. Energy observed means endothermic, energy released means exothermic. So endothermic. So now unipositive ion formed. From there also we can remove one more electron. So X plus is there. This is successive like electron removed. Successive IE1, IE2. Successive ionization energy we can call unipositive ion. So unipositive ion, again I am giving some energy. That energy only called as IE. So giving X plus, X2 plus. Dipositive ion we can call dipositive. Because already unipositive ion is there. From there one more electron is getting removed. Dipositive ion plus one more electron. So this is IE2. Why? Because we remove the electron from unipositive ion. Unipositive ion means IE1. So dipositive means IE2. And for example, if we remove the third electron means IE3. X2 plus, sorry, plus energy. That energy we can write simply IE, ionization energy. X3 plus one more electron. This is IE3. So generally tell me now, IE1 is greater or IE2 is greater or IE3 is greater? Which one is greater in this IE1 and IE2 and IE3? So at that time I can say IE3. Why? Because for removing of first electron it is very easy because it's outermost shell. And then the next electron is little difficult to remove. So that's why IE1 is less than to that of IE2. Next IE3. Okay, so this is the order and these all are endothermic process. And if you write for units of this one, units for ionization energy. What are the units for ionization energies? One is for electron volts per atom. So one atom needs how many electron volts energy? So that is one. And next, kilojoule per mole. So for 1 mole of atoms, if you want to remove it, 1 mole of atoms if you want to remove means how many kilojoules energy required? And or else we can write in kilocalories also, kilocalories per mole. Okay, these three are general units of ionization energy. So this is about ionization energy. So what we discussed here, we will revise again. So ionization energy means the amount of energy required to remove an electron from the outermost shell of an isolated neutral atom. Okay, so here we have taken one atom, it has two shells. So the last one is outermost shell. The attraction between the nucleus and the outermost shell will be less, so that's the electron. So how much energy we need to remove that electron is called the ionization energy. And isolated means like one individual atom we have to take, and gaseous atom means any gas like chlorine. Why? Because why we are taking gaseous atom means the atoms are loosely packed, molecules are loosely packed in the gaseous atom. Next, neutral, it should be neutral. So X plus energy, it gives X plus it is removing one electron and forming unipositive ion. So E electron got removed, E minus is electron. Next, this is I1. Why? Because the amount of energy required to remove first electron from neutral atom is called as I1. If you remove from unipositive means that is called dipositive, I2. If you remove from dipositive ion means that is called IE3. So in these three, IE1 is less than IE2 is less than IE3. IE3 is maximum. Why? Because the third electron to remove. More energy needed to remove the third electron. So units of these are electron volts per atom, kilojoules per mole, and kilocalorie per mole also. So in the next class, I hope you understood this class. So in the next class, we are going to continue with the factors affecting the ionization energy and also variation in the groups and periods. So next also we'll do some previous year JEE questions and NEET questions we'll solve. So thanks for watching. Keep supporting me. Thank you.